Assalamu alaikum. Bismillahirrahmanirrahim. Rabbi Shari Sadri wa Yassirli Amri Wahlul Uqdatam min Lisani Yafqahu Qawli Rabbi Zidni Ilma. Okay, children, today we are here for the revision, a very quick revision of chapter number 10, Boolean logic, the chapter that you normally enjoy a lot. That is very easy also, but let's very quickly recap that what you need to prepare for your exam. The objectives of this chapter are mentioned here. They are there to identify and know the use of the standard logic gates, which are your NOT gate, AND gate, OR gate, NAND, NO, and XOR or XOR, exclusive, or whatever you want to call. Then you need to know how to use the logic gates to create logic circuits. Like creation of the logic circuit is going to be here, and you are given a problem, or you may be given a logic expression to form the logic circuit, or you may be given a truth table, and from the truth table you will be making the logic circuit. Similarly, you are asked to complete the truth tables only, like sometimes they only give you the question that complete the truth table, and they give you a given problem, or they may give you an expression, or they may give you a circuit, which is normally the case in many of the cases, that you are given a complete circuit to make the truth table from. You are also asked to write a logic expression, and be very cautious whenever we are doing it. Be very cautious. You are asked to write a logic expression from the given problem, or you are asked to write a logic expression from the logic circuit or from the truth table. So let's start. The very first thing that we need to know is where the logic circuits or the logic gates are present. So basically, when you talk about the formation of the electronic circuits, whether they are present in the computers, or whether they're talking about the SSDs, or whether any device that we are using, they all are making use of electronic circuits, and these electronic circuits are formed from the logic gates. Now you can see here there are maybe thousands of logic gates that are needed to form a complete complex circuit, or maybe there can be lesser also. And remember one thing, what is a circuit basically? When you combine the logic gate, then they form a circuit. And these logic gates are going to get some inputs, and these inputs are going to be in the binary form, or you can say the values are going to be true or false. The values are going to be on or off, or you can call them with a value of 0 or 1. I mean, all are okay, whether you call it 0, 1, whether you say true or false, they all mean the same. Now, it is going to be like these are the 6 logic circuits that we are going to first of all discuss, and the very first one, NOT gate. Just one thing that you need to know about it is this is the symbol for the NOT gate. It's simply a triangle. Draw it nicely with the help of a pencil, carry a scale with you, and then inshallah you will be through with drawing the circuit properly, and the logic gates properly also. So this is your simple please, this is the symbol for your NOT gate, and like this is the symbol for the NOT gate. And what is it actually? The output X is 1 if the input is A is a 0. And one more thing that you can see here about the NOT gate is this is the only gate that gets one input only. This is one input only. And all other gates, if you see the NOT gate, the apart from NOT gate and or NAND, etc., they all have 2 inputs. So what is the definition? The definition is written here. The output X is 1 if input A is 0. Input A is 0, the result is a 1. The input A is 1, the result is a 0. So it's basically working like an inverter. Whatever the inputs are going to be reversed, and that is what the purpose of this thing is. Are you clear about this? Now moving to the AND gate. What is the AND gate? Basically, AND is simply the multiplication. You can call this as multiplication also. And by the way, just a minute. Now, AND gate as getting 2 inputs, as you can see here, and output X is 1 if both inputs A and B are 1. So this is the discussion about the AND gate. If both inputs are 1, only then the result is a 1. In all other cases, the result is a 0. So you can see here, it's very simple. The result is going to be 0, 0 is a 0, which is A dot B. 0, 1 is a 0, which is again, like the value is going to be multiplied. And then you can see 1 dot 0 is also a 0. And only 1 dot 1 is a 1. And this is what is the function of the AND gate. And you can see here, it's written in this manner as A dot B. and a bar. Basically, NOT gate is represented by the bar. So this is how we represent the NOT gate. Then OR gate is any one input being true, any one input being 1, the result is a 1. So the discussion or the description about it is output X is 1 if either A or B or both are 1. So why am I talking about these descriptions also? Because you may get a question that is asking you to describe. You may get a question that is asking you to talk about the like giving you the hint that that thing that which logic gate are we talking about, and questions like this have come in the paper. Like, it is not something that I'm saying that it may come, it has come in the paper. So be prepared that this is how you need to be very clear about your answers, and your answers will be accurate. Output A, X is 1 if either A or B or both are 1. If A is 1, B is 1, or both are 1, then definitely the output is a 1. As you can see here, 0 or 0 is a 0. In all other cases, the value is a 1. And how do we represent? It's represented by A plus B in Boolean algebra, and it is represented as A or B as a logic expression. So be clear, this is what you need to know, A and B, or you say A dot B, you say X equals to not A. This is what is the complete representation of the 3 logic gates that are the main gates that they talk about. They want you to do it in the same manner every time. Are you clear about this? May I move ahead? Now, if you have understood these logic gates, then believe in me, the NOT gate, if you have understood the working of the AND gate and the OR gate, then NOR and NAND become very easy. When this is what we can do. You can see here, AND was 0, 0, 0, 1, and NAND will be 1, 1, 1, 0. I'm talking about the final result X, as you can see here. So for just to keep your life very simple, just to keep your life very easy, this is what we can suggest, that you can simply write it down in this manner, that you say the opposites of and or are your NAND and NOR. Very simple. So this is how we represent 2 inputs taken, AB, moving to the AND gate. This is the representation of the AND gate, and then this is the knotting symbol, or you can say this is the this is representing the knotting process. So whether you see this as a small circle in NOT gate, whether you see that in the NAND gate or NOT gate, they all mean the same. So NAND is basically the reverse of and that is what you can see here. The result is 1, 1, 1, 0. What is the description? Again, I'm concentrating on the description because again, we can get a question like this also, and be well prepared for answering this also. Output X is 1 if input A and input B are both not 1. That is what is the main description. So if you are given this, then you need to understand and then answer it. Moving to the NOR gate, as I said, the reverse of OR gate. So since the OR gate was 1, 1, 1, 0, 1, 1, 1. So here we can see the NOR gate will be 1, 0, 0, 0. Just very simple. And one more thing that you can see here, the outputs are 4 when the inputs are 2, and the outputs were 2 when the input was 1. So moving to the last gate that is in our syllabus, and that is XOR gate or XOR gate or exclusive OR gate. I mean, no matter what you want to call it. And again, let me tell you, this has come once in the paper. They have asked you to describe the XOR gate, and it is very simple. Output X is 1 if input A is 1 and input B is 0, or output X is 1 if input B is 1 and input A is 0. And let me make it very simple. You can even say it just for your own self. If inputs are opposites, the result is a 1. Same inputs, the result is a 0. Opposite inputs, the result is a 1. Very, very simple. I mean, that will not make your life difficult at all. If you remember, opposites are 1, same is a 0. Whether it is 0, 0, it is a 0. As you can see here, 0, 0 is similar. That is also going to give you the answer as a 0 in the final column or the column X. And just be very clear, I'm just repeating, the X is representation of the output. And if your paper carries the word Y, carries the letter Y, so you have to keep the same. Do not think that we have learned X, so it will be X every time. You have to use the same symbol, the same variable, or the same letter as is present in your question paper. So these are small things that you really need to take very good care of in order to answer. These questions are simple, like very easy to answer, and you can gain the marks. Another one is 1, 1, similar. Again, you can see similar is going to give you the value of 0. So just for the purpose of simplicity, and how do we draw? Again, you can see if you have learned the drawing of the OR gate, then in this manner, the NOR is simply the knotting symbol, the symbol, the small bubble. And similarly, the XOR gate is, or XOR gate is simply the use of an arc that is drawn before the OR gate to make the XOR gate. So any questions regarding the working of this before I proceed to the next thing? Any questions before about the logic symbols? Now, and again, a representation of the same, as you can see here, if you have any query, then you can just write it down in the chat also, and then I'll be able to solve your problem. So again, a repetition. How can you represent A dot B, A plus B, or A bar? A bar is a representation of the knot. And just moving back to this, just for the purpose of, see, A dot B was and when you put a bar over it, that becomes the NAND gate. How do you write it? It's very simple. A NAND B. Achha, by the way, I normally get a question from the students quite often that means, can we write it, the gates and the symbols in small letter? Please, no, do not do this at all. You always see them in capital, so please always write them in capital. Never ever use the small letters for these gates or the inputs also. So you can see inputs are in capital, keep them in capital. Do not change them, just be a little cautious, and then inshallah you will be giving the good like impression on the examiner that the students who are attempting the paper, they know these basic principles. So any question before I proceed to the next one? A plus B bar is a representation of the A nor B, as you can see here, A nor B, giving a space in between, and A XOR B or A XOR B, and this is again very simple, A dot B dash plus A dash dot B. So maybe you cannot see the, okay, now just let me draw A dot B dash or A dot B bar plus A bar dot B. Achha, by the way, you will come across very easily, that why is it done like this very quickly. So may I move to the next topic? It's clear to everyone. Like I have got the clear thing from one of the students. So what about the others? Okay, now moving to the next topic, and that is the logic circuit, logic expressions, truth tables, and problem statements. What are we supposed to do? Now, you can see they have given you a problem, and you need to, first of all, understand what the problem is. So given a problem, you need to understand what it is, and you have to frame a logic expression, logic circuit, or the truth table. So let's start from the worked example, and you can, okay, now this is the worked example. A safety system uses three inputs to a logic circuit. An alarm X sounds if input A represents on. Input A represents on means it is basically 1. And now this is what you can do even in the paper. And input B represents off or. Now you can see this or is simply the word is written here, and they can represent it in the form of the or gate here also. Or if input B represents on and input C represents off. So first of all, just try to comprehend this equation, this expression, this question. And you can see input A is on, means input A is on, A equals to 1. And input B represents off, and B equals to not 1. So by the way, there are other ways also. I'll talk about that also, which is something that is coming in our paper also. So let's start with this basic thing that is already done for us, and then we are going to talk about the alternates also. This is the representation of A is on and B is off. O, and this or is going to come in the middle. If input B is on and input C is off, input B is on and input C is off. So this is the first step. Whenever you are given a question, then you need to convert it into its equivalent expression first, and then you can start attempting. Any questions till now? Any questions till now before I proceed to the writing of the other way that we normally use in order to answer this question? Beta, any questions before I proceed? Now, let's talk about that. What can we do? We can simply do it in this manner. I can simply say X equals to 1, and please be very, very clear. Whatever we are doing at the moment, you have to do it in the same manner. I will say X equals to 1 if, and I can simply put the first bracket, and this bracket is going to be A and B. This is the A and not B. Since B is off, that's why I will represent it as not B. Are we all clear about the first bracket? How did we interpret this? X equals to 1. If A was 1, that is why I simply wrote A, and because of the word and then we wrote the, and then we talked about the not B because the B was off. And B off means it is not B. Rather than writing 0 or in this manner, we can simply put not B. That's perfectly okay. And we are done with understanding and making the first bracket. Now we are moving to the second one, and let me put it in just to make you understand. I'm putting it in just a different manner so you can comprehend this. This is what is the main thing. I mean, just for the purpose of understanding. Now we are going to talk about the second bracket. The second bracket or the second equation, you can say, or the second situation is input B is off, on, and C is off. Input B is on means I will say not B because input B is presenting the, I'm sorry, B is on and C is off. So I will say not C. So this is a better thing that you can use in order to answer your questions. And this is the beginning. We have made the logic expression from the given question, from the given situation. Now moving to the drawing of the circuit. Again, drawing of the circuit is very easy. Let me take this example first. It says A and not B. First thing is, since there are three signals, that's why there will be A, B, C. You will draw them. Look very carefully that what are the symbols that are being used. A, B, C. You will take A, B, C. And you can see here A and not B. So what is drawn here? Very simple. You will simply take a signal from A like this, and you will be taking it to the AND gate. This is your AND gate. So it is A and then you are getting one signal coming from B. But before connecting it to the AND gate, you have to perform the NOT first. As you can see, NOT is closer to B as compared to AND. This is what you need to be a little bit cautious about. Since NOT B is more closer to NOT, so that is why you have to draw the NOT first, and then you will be connecting it to the AND gate. And then O, and then after that it is B and not C. Since B is now not, it's not. So that is why be very cautious that you have to draw B from here. Please, children, be very, very cautious. These are the small mistakes made by the children when they are attempting the paper in hurry or I don't know, in pressure or whatever. Just read the question thoroughly and then answer. B will be, since it is not, it is B positive, or B is 1. That's why you have to draw it from here. B going to the AND gate, and then you will draw the C, and then C is not it first, and then you're going to connect it to the AND gate. And lastly, it is the OR operation that is done in the end before we end it with the X. So this is how we draw the circuit. So is there any confusion in comprehending the circuit drawing, or is it clear, everyone? You children, everyone is okay with this? Every one of you, please. And then I'll talk about a few other things that you need to see, that you need to observe yourself. By the way, if you observe, both the NOT gates are in line with each other. Both the AND gates are in line with each other. And the way it is being drawn, you can see it's not drawn inappropriately. It's drawn in such a manner that you are definitely giving a good impression to the examiner that how have you drawn it. And please use a pencil. That is what is the basic instruction written for you. So to take pencil, erasers, scales with you, not the correction fluid. Only take these stationary items. Okay, any questions? Now moving to the formation of this circuit. After formation of the circuit, we are going to move to the truth table. But before that, let me talk about one important thing, that moving back to the NOT gate. NOT gate was getting one input. That's why it was producing total of two outcomes. This is the formula. 2 power 1 means one input means two outcomes. If there are two inputs, as were the case with all the gates except for the NOT gate, you are getting four outcomes as you saw. It is 0, 0, 0, 1, 1, 0, and 1, 1. And when you talk about these are your three inputs. And then the number of outcomes will be 8. As you can see here, 2 power 3 is going to be 8. By the way, although a question like this hasn't come in the paper yet, but a 1 mark question can come in the paper asking you that how many outcomes there are based on the inputs. Like if they can say to maybe there are 5 inputs. So you simply need to know 2 power inputs equals to the number of outcomes. And this number of outcomes mean that this is what we are talking about. The number of outcomes means how many possibilities there are. So now, if there, since there are three inputs, that's where you can see A, B, C, and this is what you need to know. You, if you have, should now again learning the trick. Normally they give you all this thing up till now, but in case they don't give you, just giving the thinking of a situation if you're not given. So what you need to know, this is how the you can remember. Let me tell you both the methods. The ones who are okay with learning vertically, so it is 4041, then 20, twice one, then double zero, double one. And lastly, the last column C is going to contain 01010101. So this is what is the simple thing that you need to know in order to ask it. Now, just let me take you to the book. And here we can see there is one, this is the book. And this is what I want you to pay attention to. They've just drawn it for you, ABC 1, 2, 3, 4, 5, 6, 7, 8. And there are four inputs, A, B, C, D. And here we can see 2 power 4 means there will be total of how many outcomes? I know the answer. Although the it's shown to you, but still 2 power 4. There are four inputs, A, B, C, D. So here the number of outcomes will be. Yes, children, I'm waiting for the answer, please. Just helping you out that maybe I can get a question like this in the paper. A 1 mark question can come in the paper. Come on, I'm waiting for the answers, please. How many outputs are there? You can see for yourself. There are 16 outputs. Either you calculate them, that is not a good idea. Just put the formula, the one that we talk about right now. 2 power 4. Four inputs are there. It means it will be 16. So are you all clear about this? Any questions? Okay, now moving to how to frame how to make the truth table. So what we do, first thing is we can see A and not B or B and not C. So what is done? We need to use intermediate values. Again, a suggestion, always use intermediate values. Do not leave it. A sincere advice, because if you are leaving the intermediate values, and maybe, for example, just giving an example, intermediate values were correct and the output, maybe one or two outputs were incorrect. So if you have done the intermediate values properly, the examiners know that you know. And it is always suggested that you have to do it. Acha, Azan is going on. Give me 2 minutes till Azan finishes and then we'll proceed. And in the meantime, you can go through this also. While Azan was going on, I did one thing that you can definitely do just to keep yourself away from any sort of problem. This is what you can do. I suggest. I mean, this is again a suggestion. Up to you. Decision is yours. But again, a suggestion that you always show the values before you start your work. So, you can see here. A is 1 and B is not 1. That was my first column. Intermediate values or working space is given to you, and A is 0 and B is 1. And it is and. So definitely the answer is 0. Again, a suggestion. You either make a separate column for not B, or, I mean, this is what I normally do. I make a separate column for not B or not C, and then I do accordingly. And then you can see for yourself, or you do it with a pencil yourself. That's perfectly okay. So I did it with a pencil just to make it very clear. So it is basically A is a 0 and B is a 1. So definitely the result is a 0. A is 0, B is 1, again the result is 0. A is 0, B is 0, the result is a 0. A is 0, B is 0, that not B, not B. Again a 0. Then it is a 1 and they both are 1. See, A is 1 and not B is also 1. So the result is going to be a 1. Then A is 1 and not B is also 1. The result is a 1. A is 1, not B is a 0. The result is a 0. A is 1, not B is a 0. The result is a 0. So this is how you have found the values for the first column, which is A equals to 1 and B equals to not 1. Any questions? How to work on this? They're very simple. Now moving to, just if there are no questions, then let me move to the second one. And again, C is now done for you. C is noted, and you can see 1, 0 became a 1, 1 a 0, 0, 1, 1 became a 0, 0 became a 1, 1 became a 0, 0 became a 1, and 1 became a 0. So in this manner, you have worked on the values for not C also. And then the next stage is simply to work on the final value. And here we can see B is the next one is B1 and C naught, C naught. So B1, you will look for, be careful, you will look for these. Acha, by the way, in that case, what you can do is you can simply erase them. Again, a sincere advice for those children who think that they are making, they may make a mistake, beta, it may happen. A suggestion, either you make a separate column for not B, a very sincere advice that you make a separate column for not B, here, like this. You make a separate column for not B. You make a separate column for not C. That is suggested. And then do the work accordingly. I mean, there is no harm in making another column. Rather than making a mistake and losing marks in simple topics, it's better if you do it that way. And then you can see B is a 0 and not C is a 1. The result is a 0. B is a 0 and the not C is a 0. The result is a 0. B is 1, not C is 1. The result is a 1. B is 1 and not C is a 0. The result is a 0. B is 0 and it's not C is a 1. Again, the result is a 0. B is 0, it's 0, the result is a 0. B is 1, not C is 1, the result is a 1. B is 0 and C, like B is 1, not C is a 0, and again the result is a 0. So this is how you can get the values for the second, and this is done for the first second column. Any questions? Now the last column is simply the use of an OR, and you know OR means any one input a 1, the result is a 1. Simple. Like again, giving you an example just to make you understand, we have done the programming. In pseudocode also we know that OR means any one condition being true, the result is true. So exactly the same, just remember these same concepts that you have learned and apply them here. Now, just very quickly. Now, we have to refer to these two columns and we are going to talk about these two columns only, and we will look for the OR. We will apply the OR gate. 0, 0 is a 0, 0, 0 is a 0, 0, 1 is a 1, any one value of 1, the result is a 1, 0, 0 is a 0, 1, 0 is a 1, 1, 0 a 1, 0, 1 is a 1, and 0, 0 is a 0. And in this manner, you will be able to get your answer. And maybe it's a 4-mark question. Normally, this is what is given to you. A 4-mark question, you have got the answers. Any questions? So we have understood one basic thing. The very basic thing is that you are given a situation in English and you have to interpret this and make a logic expression. And you can even, from the logic expression, you can make a truth table also. And this is what is okay. Fine. Any questions before we proceed to the next topic? Now, there is a sample question and sample questions and answers. So let's do it very quickly and you can just refer. Now, just do it very quickly. X equals to A and B or not B and C. Again, you can see there is no 1, 0 here. They've mentioned it in the right way, the way it is coming in our paper. So you can see here, x equals to A and B. X is my final output column. O, not B and C. Come on, very quickly. The working space is given to you and you are supposed to make the truth table first, and you have to draw the circuit for the unsimplified logic expression. Each logic gate must have a maximum of 2 inputs. So they have given you this very clearly just so that you can see for yourself. Each logic gate will be getting maximum of 2 inputs. Come on, children, very quickly send me the work after doing this. Okay, now just giving you a little of the hint. The first one will be A and B. And then you can work on not B and C, again up to you. You want to make a separate one for not B, or you want to do it without the not B, like up to your decision is entirely yours. But again, my sincere advice is just to work in the same manner. Then you have not B, and then you have lastly not B and C. Yes, children, are you doing it? See, A and B. A and B means that you will be looking for the values in these columns, A, B. And you can see for yourself, A, B means it will be, come on, be quick. A and B. May I get the answers from your end? 0 and 0? The result is a 0. 0 and 0, the result is again a 0. 0 and 1, the result is a 0. And then 0 and 1, the result is a 0. 1 and 0 as the result is a 0. 1 and 0, the result is a 0. 1 and 1, the result is a 1. 1 and 1, the result is a 1. So this is the working space for A and B. Now moving to not B. Not B means simply the reversal, the opposite of B. So it will be 1, 1, because 0 becomes 0, 1, 0 become a 0, and 0 is going to be converted to a 1. So 0 become a 1, 0 become a 1, 1 become a 0, 1 become a 0 here, 0 becomes a 1 here, 0 becomes a 1 here, 1 became a 0 here, and 1 became a 0 here. So this is going to be your not B. And then lastly, it is not B and C. So not B, you will take this column and you will look for the values in column C. And you will apply the AND operation. Remember, not B and C. So not B is 1, C is 0. The result is going to be a 0 here. 1 and 1, the result is a 1. 0, 0, the result is a 0. 1 and 0, the result is going to be a 0 here. 0 and 1, the result is going to be a 0 here. 1 and 1, the result is a 1. 0 and 0, the result is a 0. And lastly, 1 and 0, the result is a 0. So you can see this is how you have done this accurately, then your chances of making an error are going to be reduced to a great extent. And finally, we have